Hello. Welcome. Wasn't sure you were going to be here today. Um, Magical journey to the end of the packet, people. Get there, get there, get there. All right, we're going all the way to the back, all the way to lesson number 35. There we go. All right, one-step equation word problems here. So, hold on. No. I said all the way to the back. Lesson 37, one-step inequality word problems. Okay, so what we're dealing with here is still our equations, but not really. Like the writing format is the same, but we're using our inequality symbol. So we're going to see different words. Like as we read through question 1 here, it says Jim weighs 165 pounds and wants to go sailing with a friend. The weight on the boat cannot be greater than 350 pounds. It's a small boat, people. It's not a big boat there. All right. Write and solve an inequality to determine how much Jim's friend can weigh. So like we saw before, writing out an equation is not an easy thing to do. So we're encouraging you to kind of solve it at first and then realize when you set it up, it's going to be the opposites there. So I know, all right, that 165 plus 350. So I can only up to 350. So, okay, so only up to 350. So that means that it needs to be less than or equal to 350. Okay? Cannot be greater than 350 pounds. Boat's going to sink if it is. That's what they're saying here. So the idea is the two friends weighing together have to be less than amount. So together, so we're going to be adding this here. So they're saying the two people added together. So notice how it's all done in pieces and in chunks. And I actually found it easier to deal with the end of the problem rather than at the very beginning. So I'm going to subtract 165. And a lot of you might have in your head had that you were going to subtract 165 right away. So x needs to be less than or equal to, let's see, a little borrowing. All right. How about a 5? How about an 8 and a 1? So it needs to be less than or equal to 185 pounds. So we like our marker. We like our 185. We're going to shade it in, and we're going to shade. Oh, wait a second. Can someone weigh a negative amount? No. So here's the thing. Like, if you did this, I'm fine with it. If you made it into a compound, like, listen, it can't be below 0, otherwise, yeah, all right, can't weigh that much. Anyway, I don't know, maybe he's bringing some food on board, okay? But no, it says it's a friend. Anyway, I don't want you to get caught up in that. We're into less. It needs to be less than or equal to 185 pounds. So when we look at there, is 160 a solution? Well, 160, yeah, that would be over here, so we would say a yes. Is 186 a possible solution? Well, no, because that would be to the right of 185, and that's not where we shaded. Is 185 a solution? Yes, because it needs to be less than or equal to that amount. Let's try another one here. Students in the school band are selling calendars for fundraisers. They earn 40 cents for each calendar they sell. Their goal is to earn more than $327. Okay, so again, I'm finding it's easier to realize more than $327. I want it to be bigger than $327. All right, so they get 40 cents for each of them. And we're going to multiply. Because if we've got 40 cents, that's our multiplication problem. So when we multiply it by the number of calendars, we want to be greater than 327. So we'll divide both sides by that 40 cents. I'm going to reach for my calculator here because I don't know that off the top of my head. Unless you got it for me. Do you? No? All right. Well, just hold on a second then. Here we go. 817.5. Okay. So x needs to be greater than 817.5. So again, I've got my 0 here. I've got my 817.5. It needs to be greater than that amount. So open circle, and we're going to shade to the right. That's there. Okay. So is 817 a solution? No, that's going to get me just under it. So we're going to say no, that's there. 818. Yes, that is to the right of that 817. So that's a yes. Is 700 a solution? No, because 700 would be to the left. So again, we're using the visual that's here, our graph, in order for us to figure out what our answers are at. Does that make sense? Okay, all right. Let's try another one then. All right. 6 increased by a number is at least 18. Okay, it's at least 18. So the smallest I want it to be is 18, which means I want it to be greater than or equal to 18, because I want that to be the smallest that's there. So whatever the number is here, I want it to be greater than or equal to 18. So we've got 6 increased by a number, so we are increasing it. That's there. Yeah. So yeah, we'll subtract our 6, and x is greater than or equal to 12. And again, if we think about it, is I want to find all the possible numbers that when I add 6 onto it, it's going to be greater than or equal to 18. And 6 plus 12 is 18, so that's the smallest possible one. So I got me a 0, I got me a 12. We are shading it in because of the or equal to symbol, and we are shading to the right because that's where numbers are greater than that 12. Okay, so is 7 a possible solution? No. Again, if I'm looking at 7, 7 will be somewhere over here. It's not been shaded. Is 15? Yes, it's to the right of a 12. Is 12 a solution? Yes, it is, because it's shaded in. So we're saying, yes, we're good with that one there. All right. Looks like the last one that's there. Yeah, all right, we can do this, people. We can do this. All right, you earn $8.20 per hour at your summer job. Write, solve, and graph an inequality that represents the number of hours you need to work in order to buy a smartphone that costs $399. Okay, so if I was going to be doing this problem, I would be taking my $399 and I would divide it by that $8.20. So what that tells me is when I write this out, I'm not going to use a division. Remember, that's what we're going to do to solve it, which means it must be a multiplication problem that's there. Now, if you notice, I'm using a greater than or equal to symbol because I need more money. I need at least $399. I'll take more, but it can't be less. So $399, we're good with that. Anything less than that? No, thank you. Not going to be enough. And yeah, we're multiplying by the number of hours. So there's that we're dividing by. And again, you can see it. It showed up. It's right there. All right, there it goes. We just did it there. So again, that's how we can kind of use it to help ourselves out. I'll punch in the calculator here. Don't worry, people, I got you. $399 divided by $8.20. Oh my, all right. I get a 48.65 658.5365, whatever that's there. So the question is how many hours are we going to work? Okay. So when we look at our visual here, all right, okay, I've got a 0, and then I've got this 48.658, yada, 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 all right? So it can be that amount, or it needs to be bigger. Now, since we're just talking about hours here, we're going to be using that whole number that's there. So in this case here, the next whole number on that shaded portion would be 49, all right? So let's go back to the question. Write, solve, and graph. I wrote, I solved, I graphed. That represents the number of hours you need to work. So yeah, I need to work 49 hours or more. Nothing wrong with doing some extra work, people. Get some extra money, all right, to take care of your summer extravaganzas. That's there, all right. Go bring the register. All right. So again, a lot of kind of going back and checking, is it realistic? And then realizing we can use the visual to help us understand what we're dealing with. We're done here, people. Enjoy.